In the last session, we had talked about like our hierarchical clustering. We have learned like how to do clustering with the STP framework, STP for a
And I think we talked about algorithm.
algorithm.
Yes,
Okay. We have talked about STP framework for a revision. I am trying to like explain little bit about this again. So these are our clusters, right?
yes,
So the full form of STP is segmentation, targeting, and positioning. You know that already, right?
yes.
STP's full form is segmentation,
Fragmentation,
targeting. What is the P stands for?
segmentation, targeting, I think,
Positioning.
position,
Yeah.
position.
If you have any doubt between the session, you can ask me that, right? So this is the full form of STP framework.
Mm.
So clusters
Okay.
are formed by keeping in mind the patterns of their differences and similarities. I have told you between the clusters or the clusters are basically based on difference and similarities, right? Differences and
Yes,
similarities. What
difference and
differences they have or what
similarity.
similarities they have,
And
right?
I think repetition or like
Yeah,
that.
repetition
Repeat.
or something like that.
Uh,
So what should be the distance between the clusters? What should be the minimum and along the clusters? What should be the distance? So I think you have remembered these distance properties I have told you, or if you have note of that, our distance properties.
yes, distance.
What are our different distance properties?
Some distance is longer, but I think we wanted to
Have you remembered
choose.
this thing? Dij.
Yes, yes,
Dij is equals to, no, sorry. Dij is bigger than 0.
yes,
Have you remembered
yes,
these things I have told you?
yes. And distance D to J is bigger than DR.
Yeah, Dii is equals to 0 because they
Yes.
don't have any like
Mhm.
distance. Dij
Mm.
is equals to dji, and this is we called symmetry. And one more thing is there, triangular inequality.
Mm.
I think I have not told you this thing, triangular inequality, right? The formula for
Right.
that is uh dij plus dik is equal sorry, bigger than. So that means dij plus dik, like two different points, the distance between them is equal, if we add that, is bigger than dik, a single point, right?
Mhm.
So
Right.
these are some our basic distance properties I have already told you.
And I think you draw something like triangle.
Yeah, this triangle
Okay.
dik.
Yeah. Yes. Yes.
Yeah,
Okay.
so I have told you these things already, right? So
Yes.
you have a note up for that. Have you noted everything? Can I remove this?
Yes. And you can use.
So after that, we had just talked about distance and some properties of distance. So all this stuff we had to read. And now let us move ahead on our points like, first of all, let me talk further in theory about how many types of distances are there, right? How many distances we have there. And how many distances are there and where and how we use them. So first of all, our basic and most important distance came in a picture. The name of this distance is Euclidean distance. I have not discussed about Euclidean distance yet, I think, right?
Yes.
Euclidean. distance. I'm increasing my speed. If you have any confusion in the spelling, you can ask me, right? Okay.
Okay. But the
See, if
point
if
in
I have already discussed this, I have already told you something about Manhattan distance or statistical distance.
okay.
Have I don't think we have discussed about that.
No, I think it was at the mass.
Okay, no problem. We
Okay.
can also like revise these things. So, first of all, we are discussing about our Euclidean distance.
Yes.
In this
Okay.
distance, you have to remember only one thing, that we keep our focus on standard deviation and our normalization. We have already discussed about what is standardization and normalization, right?
Yes.
So we have to focus on standardization, right? Do you remember what is standardization or normalization?
Standard deviation is is in the max balance. Uh,
Do you have notes for standardization or
yes.
normalization?
Yes.
Kindly go through that
Measure.
after the session
Yes.
so you will
Okay.
remember what is the standardization, what is the
Okay.
normalization, and what's the difference
Yes.
between these two things. Okay.
Yes. Yes.
So currently we are talking about Euclidean distance for the so the formula for Euclidean distance is z is equals to x minus mean upon standard deviation. Okay.
Okay.
So see, first of all, I have to told you like I think I have already told you guys about that whenever I am talking about these formulas, these are for only for our knowledge. In Python, we can do everything without the formula or something like that. Okay. So I am only telling you these things for your own knowledge to remember these things. If someone from a interview team or any teacher or anyone would ask you so that like what is the Euclidean distance, what is the formula for that, so you can tell them like I know the formula. I'm not only dependent on the Python or the libraries, right? So now we have talked about what standard deviation and normalizations are, and their formulas are our technique of measuring distance in Manhattan distance. So, first of all, in hierarchical clustering, we have two things. I think I have already told you this. Agnes and Diana. I have told you, right? About Agnes and Diana.
Okay.
Remember?
Diana, yes, but not Agnes.
Okay. No worries. I will tell you this later. So this is a short summary about Euclidean distance. What is Euclidean distance? Okay. So our next thing is Manhattan distance. Sorry. Keep on taking the notes.
Yes.
Manhattan distance. And the formula for that is Dij is equals to keep uh, xi1 minus xj1 plus xi2 minus x j2 and so on. Okay.
Okay.
Formula will look like that. And for say x I j k1 k2 l1 l2 and so on, whatever points we have, whatever how many like clusters we have, that things or how many data points we have, that thing doesn't matter. Like we can also say xip minus xjp, right? P is
Yes.
standing for unlimited. Like how many data points we have, that thing doesn't matter. So this is the basic formula for Manhattan distance. Okay.
Okay.
After that, the distance we learn is our statistical distance. Statistical distance. We have already we already uh like this distance have another name, very famous name. The main the name is man. This is little bit different to pronounce. The name is man al anobis. Okay.
Yes.
So if we also know it by the name of you can say man in a nobby or something like that. But this is a simple name, statistical distance. So this we are gonna use. Now, how is the whole thing when we look at it? If you do practical work, then it will be easier than that. Like currently we are discussing the formula like for the statistical distance. We have a formula like dij is equals to under root xi minus xj square root plus 5 minus 1 and xi minus xj. So this is the basic formula for statistical distance. So what I have to say or what I am explaining you is if you do practical work, then it will be easier than that. For now, just understand that there are three of them. First one is Euclidean distance, second one is Manhattan distance, and third one is statistical distance. And they have these formulas. Okay. It has to be done in Python. It is very easy to do in Python whenever we do our hands-on practice or something like that. It is very easy. So that's why I will not talk much about that or these distances because we already have less time to finish our course. We have many things in pending, right? So, okay. So now let's go ahead and talk about our very good one thing. Can I remove this?
Yes.
Okay. So we are gonna talk about the thing that will have the most of in this in our Ukrainian distance and Manhattan distance, Euclidean distance and Manhattan distance. These
Yes.
two will be the most of them, and our statistical distance will be a little less when we are talking about our distances. Let me tell you that whenever we do these things in Python, or whenever we do these things, it becomes a matter of Euclidean statics distance. right? So all of the numerical data sets we have, what we have like discussed about till yet is talking about our numerical data. You know what is the numerical data and what is the categorical data, right?
Yes, numerical data. Yes.
So you can say,
Numeric data, for example, numbers.
yeah, whatever we have discussed right now, like Euclidean, what we have discussed in these three distances, all of these are gonna work on numerical data. That means our university data, you can also say university types of data, right?
Mhm.
So that is our numerical data. But what if we are working on a categorical data? Then how we can like find the distance, or how we calculate the distance, right? So
Right.
now we are gonna work on that. So we have just talked about our numerical data on which we use our Euclidean, Manhattan and statistical techniques to calculate the distance, right? But if we talk about our categorical data, whenever the categorical data is, and how can we calculate the distance between them or between the clusters? So for this, also there are some famous techniques. First of all, let me give you an example with the help of a data set. So the data set will look like, uh, this is the example, okay?
And that is MXA.
Mr. A, Mr. A, Mr. B, and Mr. C.
Mister. Okay.
I'm first like creating the data set, then I will told you everything. And we have some data points like N, Y, N. So these are some data points. So you can see we have a data set in which our Mr. A, B, and C is three people, okay? Or we can say these are our, sorry, 3 points. And we have also three terms where we will see whether one of them, whether one is graduate or not. This is our graduation thing, okay? One is
Correct.
graduate or not. One is an alcoholic or not,
Alcohol.
or one is a vice president of any batch or not. Okay.
Mhm.
Here we say Y stands for yes and stands for no. Yes, yes, no, no. Yes, yes, no. Yes, no, yes. Okay. So that means if we are talking about Mr. A, he is graduated. Yes. Alcoholic. Yes. Vice president. Yes. Mr. B, graduated. No. Alcoholic. Yes. Vice president. No.
Mhm.
Mr. C is graduated. No. Alcoholic. No. And vice president. Yes. So now we know that whenever we see distance between someone, we have to blame someone for that. First, you will have to find the distance between 2 points, or we can say between two people. So I'm gonna create another graph for that. See, these things are little bit hard for you, I guess, to like clear in a one time. For that, you have to like practice or invest your own mind into that, because this is not easy to explain also. So here, Mr. C, you can say, if we are currently calculating the distance between Mr. A to Mr. C, okay? This is Mr. C, and here we are gonna say Mr. A, and we have some points like we have some points like first of all and Y, no, Y. Now we have to calculate the distance between Mr. A and Mr. C. Okay. So if we see here, what is the number of no and no between Mr. A and C? So you can see Mr. A between, like this is, we are like calculating the distance between. Okay.
Okay.
So you can see like Mr. C and Mr. A have doesn't matching n, like no and no is not matching, right? They don't have no and no similar. Getting my point, Ali? So this is the zero here, right?
Okay.
If we talking about yes or no, so we have yes and no two times. You can see here, yes,
Mhm.
sorry, yes, no, yes and no. This is two times, right? So here is the
Yes.
two. If we talking about no and yes,
No, I guess.
no and yes is still
Oh,
zero,
zero.
right? And if
Yes.
we say yes and yes is
Yes,
one,
I is one.
right? So this is our graph and distance between Mr. A and Mr. C. So see, first of all, this is our, like I'm explaining you this as a theory basis. Whenever we do this thing in a Python, we don't have to calculate this way. Just we have to give a command and the distance between any data point or something is our output. Okay.
Okay.
So this is for your knowledge. And let me tell you, whenever we are working on a sorry, categorical data, whenever we are working on a categorical data, we have some techniques. So the technique is, first one is binary Euclidean Euclidean sorry, distance. Okay, binary Euclidean distance. The formula for that is b plus c upon a plus b plus c
Sir.
plus d. right?
Right. Right.
Another technique we have is simple matching coefficient. Simple matching coefficient. Simple matching coefficient. Sorry. The formula for that is A plus D in brackets A plus B plus C plus D. So this is the formula for our simple matching coefficient. The third technique we use is very famous in data science, that is Jacquard's index. Okay, Jacquard index. The formula for that is D upon A plus B plus C plus D. Okay, so here you can see what when we make this graph. So you can say this is our A point, this is our B point, this is our C, and this is D. Got it? So all of these
Okay.
distance are calculating the distance B, C, A, B, C, D. So you can see A, B, C, D. So if you want to calculate the distance of by this technique, binary Euclidean distance, simple matching coefficient, yeah, or Jacob's index, just you have to paste the values here as per the formula, and you will get the exact distance between the point, like Mr. C to Mr. A, or if you want to calculate the distance between Mr. A to Mr. B, just you have to create this graph if you are not working on a Python, right? On a theory basis, and use these formulas to get a proper distance. Is this thing clear? When we are
Okay.
working on a universal or university or numerical data, we use Euclidean, Manhattan, and statistical distance technique to calculate the distance. When we are working on a categorical data, we have to use binary, simple matching, and Jacquard's index. These
Mm.
are some famous and very useful distance calculating techniques. Still yet, if you have any doubt, you can ask me. So I will explain. If you have any doubt or something you are not clear about anything,
Everything is okay.
everything is
And
okay.
I should, yes, because that is formula.
Sorry.
It's okay. The formula is okay. My voice is clear.
Yeah. We do it our numerical data. And give me a minute. I'm saying that is anything very important to tell you, or we have like we can go further. No worries. So now look, if you have not understand any formula, if there is any confusion in the formula, or there is like anything, any doubt in your mind, you can ask me anytime, right? Related to that theory. But we have Python for everything. When we work on a Python, we do not have to worry about formulas and these things. Just we have to use our libraries, right?
Okay, libraries. Uh, okay.
Yeah.
I think there were NumPy libraries.
Sorry.
I think NumPy libraries calculated.
NumPy is for numerical value. I
The
have told you,
numerical. Okay.
yeah,
Oh, yes. Yes. Okay.
pandas for
Okay.
these types of calculations.
Thank you.
Panda and NumPy, both library is most used and most important libraries or repositories in a Python for a data science professional.
Mm,
Okay.
okay.
So can I remove this? Have you noted that?
Yes.
Okay. So now we have discussed about our numerical data and categorical data, how we calculate the distance between them, right?
Mm,
If it is numerical data, then what technique we have to use, and if it is categorical data, then what technique we have to use. You already know about that.
okay.
But now it comes to the question of our data. What if the data is what if our data is a mixed data? Do you know what is mixed data? I have told you earlier.
Mixed data and numerical and categorical.
Yeah, mixed data is numerical plus categorical data. In this case, when we have to calculate the distance of this mixed data, how can we calculate? Like we have some techniques which can only work on numerical, and we have some techniques which only work about categorical, right?
Yes.
So there are few points I have to told you what if we have mixed type of data.
Yes.
So the mixed data must should be numerical and categorical both. Then what will we do is, so here I am telling you 3 points. Just remember this now. First point
Stand.
standardize the
Standard.
numerical variable to 0 and 1. When we talked about our standardization, I have told you whenever we standardize any value, we have to keep them into 0 and 1 formula, right? Format, sorry. 0 and 1 format, right?
Okay.
Second point is categorical data is converted into dummy variables. Dummy variables using one hot encoding.
And one. Sorry.
One hot, one encoding.
One.
I will explain you this first. I'm just writing it down. Third point is calculate Euclidean distance Euclidean distance using entire is our meeting recording. Wait a minute. Yeah, we are recording. So calculate Euclidean distance using entire data. So here are our three important points. So from the first point, you can understand that we have to standardize any numerical value. What should we standardize, right?
Right.
It happens that I taught you earlier that any value that is not big, is above or below, or is big or small in the same data set, then we standardize it by changing it to 0 and 1, right? When we
Okay.
standardize
Change
any
zero.
value, we change
Okay.
into 0 and 1. I think you remember what is standardization, what is normalization.
Yes.
I had talked about to you about this earlier. The second point in some sessions is that we convert our categorical data into these dummy variables with the help of hot and encoding technique. What is and hot encoding? I will tell you whenever we do work on a Python, because it this is not a part of our theory thing. We have to do that in a practical way. Okay, what is one hot encoding? So for now, just focus on second point, like categorical data is converted into dummy variables using one hot encoding, right?
Okay.
And our third point is that we calculate the distance of entire data using Euclidean distance, or calculate the distance. If we do this, then we have already talked about our numerical data and categorical data. So in a third point, you can see calculate Euclidean distance using entire data. Entire data, like when we talked about, no worries, I will tell you in a practical way.
Okay.
Just note these points because I don't want to like create like a story or something which you are not gonna clear about. So all of these things are to work on in a practical manner. We cannot like discuss about this in a theoretical manner. Also, whenever we work on a mixed type of data, there are another very famous term, or you can say a very famous technique we use, and the name of this technique is uh, Gowers
Hours.
General Dissymmetry. Dissymmetry. Sorry, dissimilarity. Dissimilarity. Gowers General Dissimilarity. आगे था coefficient. Coefficient. In a short form, we say GGDC. Okay,
Okay.
GGDC technique. This is very famous technique to use on mixed type of data. The formula for that is, let me remember what is the formula. Dij. is equals to uh, lambda k, lambda k w I j k d I j k. Just note this formula. Like we will never gonna use this in a theoretical manner. I'm just telling you the formula because I have remember this right now. W I G K. This is the formula. Okay. Dij is equals to lambda k, wij and dijk upon lambda wij. So this is the formula we have for Gauss general dissimilarity coefficient GGDC. Right.
Right.
So I have told you there is another very famous term or technique that is governors general dissimilarity coefficient. Okay. Now, I will not talk much about it. I will only tell you the formula and you should note it down. We will see the rest of it at the time of practically how it works, where we can do it and where we cannot use this. There is no need to go into much detail in a theory about that. And this technique is for those who do like this special technique. GGDC is not for the beginners. Okay. This technique is used by who who do research or go into like some research department related to data science. Those people use these GGDC type of technique. So this is a very advanced thing, but I remember its formula, so I'm telling you to follow the knowledge on. So now just note down the formula, and now we move forward. Have you noted everything? Is there any doubt related to that?
No, because just note.
Sorry.
No, it's okay. Just noted.
Okay. So this technique is used by researchers or person who is doing PhD. Okay.
Yes.
You know what is PhD, right?
Yes.
Yeah. So a person who's trying to do PhD on data science, they will use these types of techniques or something related to that. But for beginners, we are only use these things, standardized categorical data and call like calculate the Euclidean distance. Can I remove this?
Yes.
So all we talked about till now was our distance within the cluster. Whatever we have talked about till yet is distance within the cluster. Distance within the cluster means, if this is a cluster,
Yes. Okay.
what we are still discussing is distance within the cluster. Like if this is a data point and this is a data point, distance between them, right? Distance between them
Right.
or distance between them. So what we are discussing is still distance within the clusters. Within that
Okay.
means under the cluster, the data points. Whatever data points, like the data points are categorical data, numerical data, or mixed data, whatever. But what we have discussed is about within the cluster. From what, so you can say the distance between the cluster, within the cluster is from one data point to another data point, right?
Mm. Yes.
So whatever technology there was about it, I have told you everything. We learned or knew about it and what it was. What is their formula? I have told you. But now the next thing that comes in a mind, that is distance from one cluster to another cluster. For now, we
Mm.
have discussed everything about within the cluster, right?
Okay.
Within the cluster. But
Yes.
now we are gonna discuss about,
Utility, yeah?
sorry,
No, it's okay.
discuss about between the cluster, the distance between the
Mm,
cluster, right?
right.
If this is another cluster and this is another cluster. So here we have talked about within the cluster, that means under the cluster. Now we are trying to calculate the distance between the cluster. Okay. So what and how we are gonna calculate this, I am gonna tell you. Distance between clusters. Ali, my writing is not good, right?
Oh, yes.
My writing is very bad. There is some technique for this. It is quite simple, and let us know little bit about them by name or something like that. And let us know the rest when we do hands-on practice on Python. Okay. So there are some techniques. First one is, kindly note it down. Single linkage or nearest neighbor.
Single linkage. Okay.
Single linkage, or we can say
Linkage.
nearest
Okay.
neighbor. This is another name for it. Okay.
Okay.
This is this technique is used to calculate the minimum distance between 2 points or two clusters. Okay.
Okay.
Minimum distance. Second technique is complete linkage, or you can say farthest neighbor. That means we here in this techniques we are gonna talk about maximum distance, right? Ali, are you there?
Yes.
Okay. Are you taking the notes?
Yes.
Okay. So third technique is our average linkage. Fourth one is fourth one is central linkage. In the central linkage, what we are gonna say is between centroids of two clusters. Between centroids of two clusters. Here you can see I have marked two centers, X and X, right? In
Okay.
the cluster. So these are the centroids of each cluster. In this cluster, this is the centroid. In this cluster, this is the centroid. So distance
That's
between
right.
them, to calculate the distance between them,
Mm.
we use the technique central linkage. Okay. Average linkage is average distance between and the cluster. Complete linkage of farthest neighbor is maximum distance. What is the maximum distance we have? And single linkage or nearest neighbor is minimum distance. Okay. Have you noted this?
Yeah.
So just I have just told you these four techniques, but when we like do hands-on practice, I will tell you more about that. So can I move?
Yes.
Are you taking notes, na?
Yes. I
Okay.
did it.
So now I am trying to explain something with the help of data set. Try to understand it. I am trying to explain it in a very easy way, but this thing is little bit hard. You have to like keep your mind open to learn these things. I hope you will understand. And if you don't, please ask your doubt or anything you have in your mind.
Okay.
Don't say that you have understand and after some time you are gonna ask like how these things are gonna work, because this is a important thing now. You have to focus now. So we are gonna talk about hierarchical clustering. Hierarchical clustering process. What is the process for that? Okay. So here we are gonna take an example for that. Ah, with the help of Euclidean distance. Here we are only gonna focus on our Euclidean distance. Okay.
Euclidean distance. Okay.
Hmm. Here, here in this example, we are gonna use Euclidean distance technique in theory, not in Python, in theory. So first of all, we have to create a data set. This is x1, this is item, and this is x2. Okay. And we have some random values. We will take some random values.
So 2x2
Sorry,
and 2 type x2.
like this is item, like item
I
is
know.
one,
X1 x2. Okay.
yeah, x1, x2. This is an example. We are taking some example by the values. Okay. And we are taking some random values like 1 and 1, 2 and 1, 4 and 5, or 7 and 7, or something like that, 5 and 7. Okay. So these are some random values. Now we have to use Euclidean distance to calculate the distance between each point. Between each point. Okay. For that, we have to create a a graph first. A graph for that. And a graph will look like this. So what is our points here? We have some data points like, if we are talking about x-axis, we have 0, 1, 2, 3, 4, 5, 6, and 7, right? Same
Yeah.
here. 1, sorry, 0, 1, 2, 3, 4, 5, 6, and 7. 7, 6, 5, 4, 3, 2, 1, and 0. 0, 1, 2. So we have to create a graph on this. So first one is 1 and 1. You can see first value for item 1 is, the value is 1 and 1.
Mhm. One
That
and one.
means 1, 1, and 1. Okay. The value is
Okay.
1 and 1. Right. Second value
Right.
is 2 and 1. So we use this one and this 2, right? 2 and 1.
Yes.
Third is 4 and 5. So we use this
Four
5
and five.
here. 'So this is our graph, right?
Right.
That's how we calculate on graph, right? X and
Right.
Y axis. 4 and 5. Uh, Fourth value is 7 and 7.
Seven and seven.
7 and 7. And our last value is 5 and 7, right?
Five and seven.
So what we are gonna use this 5. Just I'm giving you an example. So here is 4 and 5. Wait, I'm gonna remove this. So it is our 4 and 5, right? Yeah,
Right.
4 and 5. And this is our 5 and 7. We have pointed every value into our graph. 1 and 1, 2 and 1, 4 and 5, 7 and 7, and 5 and 7, right?
Five and seven. Yes.
So now we have to calculate Euclidean distance. When we are talking about Euclidean distance, I know we know like we have to calculate distance between every data point. Every data point is like, for example,
For example,
if
one and one.
yeah, 1 and 1, 2 and 1, 2 and 2.
And
Like
two.
for example, 1, 2, 3, 4, 5. We have five items here, right?
Yes.
Or also five values. That means 1, 2, 3, 4, and 5, right?
Yes.
Now we have to calculate the distance. How we are gonna calculate the distance? Please focus on that. What is the distance between 1 and 1? What is the distance between 1 and 1?
And one
You are
and
gonna tell
one.
me,
I think zero.
right? 0, good. What is the this is 1 and 1. That's it. What is the difference distance between 2 and 1?
Two and one.
Yeah.
I think 1.
2 and right. Good. 2 and 1 is 1. What is the distance between 2 and 2?
2 and 2, I think. 2 and 2, I think 0.
Right. Good. Now what is the difference distance between 3 and 1?
3 and
3.
1, 3.
Yeah, 3 and 1. Like this distance.
Uh,
3
2.
and 1. Not 2. Now here comes
No.
the part
Uh,
of there comes the part of or use of the formula. Right?
1.
What formula I have told you? For
Uh,
DII, when we are calculating two different calculations or values, what is the first see, first of all, we are calculating 3 and 1, right? 3
it's
and
3
1.
and
Item 3 and 1. What is the x1 value? 4, right? 4,
x1
right?
value 4. 4.
4
Okay.
minus x1 for 1 is 1.
Okay.
4 minus 1
3.
whole square plus what is the x1 sorry, x2 value for 3?
X2, 5. 1. 5 minus 1.
5 minus 1 whole square, right?
Yes.
And this is our square root. So what if
Okay.
we calculate this? 4 minus 1,
Okay.
that means 3 square.
3, 9,
4 square, that means 9
16.
plus 16. The answer is
I think the result is
the
5.
answer is 25 and the
Yes.
final answer is 5, right?
5. Yes.
So the
Yes.
distance
Okay.
between 3 and 1 is 5. You understand
Okay.
that?
Yes.
Now you are gonna calculate distance between 3 and 2 and tell me.
Okay. 3
Calculate the
and
distance
2.
3 and 2. 3 and 2,
Okay.
this one.
Okay.
Calculate
3,
this,
4. Okay. Okay.
calculate this and tell me the answer.
Okay.
Now you are gonna tell every value, every
Okay.
distance.
Okay. Uh, Route 20. Can you hear me?
Sorry, what answer you are giving?
Route 20. Route.
Root 20. What is the
Yes.
final answer? What is the final value here?
Final value route 20.
No, 20 is a root, right? Here you can see
Yes.
root 25
Route.
is a
Yes.
root. What is the final?
I don't know.
5 5 is 25, right?
Okay.
So what if 20, 20, what is the square root of 20? 4.5? When you try
Yes.
to calculate the square root
Okay. Okay. Okay.
of 20,
It's
see,
me calculate.
here's the example I'm giving you. You are calculating three distance between 3
I
and 2.
think 4 points. 4 and what's
4.5
continue?
is the answer.
Okay.
See,
4.
I'm giving you the example. 4 minus 2 whole square
4 minus a square plus 5
plus
minus 1
whole square,
square.
right? The answer
Okay.
is 4 minus 2, 2 square plus
Square. 4
4
square.
square is equals to 4 plus 16,
Mm.
right?
Yes.
20. Because here we are calculating in square root. That means the final answer is square root. But we have to remove square root whenever we are calculating a final value. So when you try to calculate square root of 20, the answer is 4.49 something, right? So whenever the value is in not in a like manner, so what we say 4.5 is the nearest. So the answer is 4.5. The distance between 3 and 2 is 4.5. Okay. What is the distance between 3 and 3? 0, right?
And 0.
Why 3 and 3? Because we don't have any distance. 3 and 2
Yes.
have some distance, 3 and 1 have some distance, but not 3 and 0, right? So this thing is clear, I think. How we are gonna calculate that? How we are gonna
It's good.
calculate Euclidean distance, right?
Right.
So as usual, if we talk about our 4 and 5, what is the value? Let me calculate
Okay.
in a faster way. 4 and 1 is 8.5. 4 and 2 is something 7.8. 4 and 3, 4 and 3 is something 3.6, and 4 and 4 is 0, right? Fifth one
Right.
is 5 and 1. 5 and 1 is 5, 7.2. 5 and 2 is something 6.7. You can calculate any value. I might be wrong, but I'm calculating in a faster manner. So I might be wrong. 2 and 2, 5 and 4, 5 and 4 is 2 and 0. So that is the graph we make, right? So
Right.
this is, sorry, this is a type of data, you can say. This is a type of data, right?
Right.
So this is a distance values we have calculated with the help of Euclidean distance technique, right? Any doubt till yet, Ali?
It's okay.
I think I have explained this in a very easy manner.
Yes.
So you don't have any doubt or something?
It's okay.
Okay. Now you know now how to calculate distance between 2 points with the help of Euclidean distance.
2.
You know the trick or the thing how we gonna calculate the distance, right?
Right.
Okay. So now the next thing is when we try to like use that, we have to create a filtered data set, or Python will create a filtered data set for us. What they do is 1 and 1 is converted into A and A. Why? I'm gonna tell you. So what is the minimum value we have here? What is the minimum number of value we have here?
And minimum number of value
Hmm.
0.
0 is not countable. When we are
Uh-huh.
talking about distance, I have told
Countable.
you
Okay. Okay. 1.
the symmetry, like the single point is not countable. The distance
Okay.
is between 2 points, not
Yes.
in the point, right?
Not zero.
I have told
Yes.
you. So we are not gonna talk about zero. The minimum distance, what is? One, right?
And one. Yes.
One is a minimum distance. That's why we are gonna start this by one. So one
Mm.
is not considered because this is the minimum value.
Okay.
That's why I have started this graph or filtered this data set, sorry, by A and A. So what is A and A? Zero. Distance between A and A is zero.
Zero.
Now we
Okay.
are gonna use this from this. Like they all of these values are gonna filter. So the graph will look like, or the data set will look like 4.5, 0, 7.8, 3.6, 0, 6.7, 2.2, 2.0, and 0. So what we have done here, we have filtered, or Python will filter, you can say. Here we are gonna, like here, we are using a theory technique or formulas, but Python, when Python give us output, that will look like that. Okay.
Okay.
So you can see the distance between 3 and A. What is A? A means 2, because we are ignoring
Two.
the minimum value, right?
Mm.
So
Okay.
3 and 2, 4 and 4.5, you can see here. 3 and 3, 0. When we are talking about 4, 4 and A, that means 2,
Able.
7.8.
Okay.
If we are ignoring the minimum value, that means all of these values are gonna cancel, right?
Remove.
So you
Okay.
can see 4 and 3, sorry, 4 and A, 7.8, 4 and 3, 3.6, 4 and 4, 0, as we calculated here.
Okay.
Take it. Yeah, sorry. So you can see we have filtered everything, right? So this is
Right.
our final data set of distance with the using of Euclidean distance. So these are the
Ability and this.
steps. This is the perfect example to calculate Euclidean distance. After that, we have to create a dendrogram, or dendrogram in a Python or whatever project we are doing. We have to create dendrogram. Also, we say it dendrogram. Both are perfect names. What is dendrogram? This is a type of chart. You can see in a browser. You can see this is a dendrogram. I think I have shown you this dendrogram, type of dendrograms, right? You can see here. Is it visible?
Yes, it's visible.
Yeah. So this is dendrogram. Same as graph we have created here. See, they have some values, they have some values here, and the values are connecting, interconnecting, right?
Right.
So this is the dendrogram. After that, we have to create dendrogram. And here we have just talking about clusters, not between the points, not within the cluster. This is the example of between the clusters, right?
Right.
So clusters is look like this. I have given you example of dendrogram. Dendrogram will look like that, right?
Right.
And all of these are number of clusters. All of these are number of clusters.
Yes.
So here is the example, complete example. Now, if you have any doubt, you can ask. This is it about hierarchical clustering. I have told you everything in a theoretical manner. So do you have any doubt?
It's okay.
Have you noted this? Everything?
Not complete. That's me.
Yeah. Note it
Some
and
it.
let me know.
Okay. Can you read?
Okay. So I think I have told you today many things about hierarchical clustering and so on. I don't want to like make a burden on you. So I'm not gonna start new thing because we don't have enough time also. We cannot complete any new topic today. So we will start our new topic on like from next week, right? So today we are just like trying to revise what we have learned till yet, right?
Study.
Yeah,
What is that? No.
libraries.
Libraries. Okay.
What we have
Okay.
studied till yet.
Okay.
What we have studied till yet is first of all our libraries, right?
Yes.
What are our libraries? I have told you.
Pandas and NiPy.
Sorry,
Pandas and NiPy.
pandas is used for.
Pandas is for
I have
uh,
told you guys to please like revise everything
mm,
daily. Pandas is
categorical
used for data manipulation,
data manipulation.
right?
Right.
Categorical data is a type of data where we can use pandas,
Mm,
but the main use of pandas is data manipulation.
okay.
Another one is NumPy.
NumPy.
Today we are just
Numerical.
revising, right?
Okay.
NumPy is used for,
No numerical data.
yeah, numerical, numerical calculations.
Okay. Thank you.
If you don't have note of it, kindly note that these libraries are very important. You have to know like which library is used for what. Next one is our matplotlib.
Math.
Matplotlib. What is the use of matplotlib?
Graph. I think that was a show graph.
Yeah, graphical representation. Present, sorry, representation. Tation. T-A-T-I-T-I-O-N. Representation. Next one is
Wi-Fi.
no. C1.
Uh-huh.
What is the use of C1?
Seaborn. I think one of Kera.
Yeah. Advanced graphical representation. Advanced format of graphs. Right. Advanced graphical representation. Same. Give me a minute. Sorry for the interruption. What is our next library? It is stat mode. Right?
Wi-Fi. Seaborn. Okay.
Stat mode. I think I have not told you this library earlier.
No, not
Stat mode.
no.
Stat mode
Mm.
is used for statistical analysis. Okay. Statistical analysis. Note that. This is also important. Nowadays, not earlier, but nowadays is important. Now, next one is scikit-learn. Scikit-learn. What is the use of scikit-learn?
I don't want circuit.
Scikit-learn, or you can also say sklearn. I have told you earlier. Learn. Machine learning.
Machine learning.
We forget everything, right? We have some more libraries name as Keras, TensorFlow,
Eros.
TensorFlow, and PyTorch.
PyTorch. Okay.
All of these three of them are used for
And I think AI or machine learning.
machine
Tensor.
learning models. This will work on models. So it will
Mhm.
also came under machine learning, right?
Right.
One is left, SciPy. SciPy is used for
Sci-fi resource and science.
scientific calculations. I have told you there are two types of
Yes.
calculators. One is only numerical, so that is NumPy. One calculator is we used in our real life is scientific calculator, right?
Yes.
So SciPy is used for scientific calculations, right?
Right.
So these are our some basic libraries. I have reminded you because it is a long time. We have not discussed about libraries. Have you noted everything? See,
And
these
not
libraries are
not
very
completely.
important if you are gonna like learn data science. These are very basic and very important. Very important.
Okay.
Noted?
It's finished now.
Also, what we have discussed in our last sessions, we have talked about libraries. What else we have talked about?
Last session I say algorithm.
I don't think I have talked about algorithm yet.
A little
Have
bit.
okay. Which algorithm we have talked about?
Just mention. Let's
Okay.
talk
Okay.
about them.
Yeah. Got it. We have already talked about hierarchical clustering, right? We have
Right.
finished it. We have finished this. Why everyone is calling me? Wait a minute. We have discussed about hierarchical clustering, right?
Right.
What we have also talked about our agglomerative clustering. The all of these things are we have already discussed about, and you have to know everything about that, right?
Oh, yes.
Also, I have told you earlier that try to do some research on your own. Like if I have like try to train you today Euclidean distance. Now you what's your work is go on the Google or somewhere and try to learn more about Euclidean distance. Okay. Self learning is important. I'm not gonna like train you everything. You have to
Mm.
do your own research, own study to learn everything we have in our data science field, right?
Okay.
I have already told you about Diana, Agnes,
Mm.
Agnes and Diana. Also, we have discussed about in our previous sessions about what we have discussed about also our methodology, crisp
Our
MLQ, basic
methodology.
thing, right?
Mm.
This is the basis, crisp MLQ. We have discussed about business understanding, data preparation, right?
Right.
Anything else? Data mining, what we have discussed about more, data cleaning, anything else? Data preparation. Oh, yeah, data preparation. Data preparation is already covered. Hmm. What more, Ali?
Mm.
What we have discussed also? Hmm.
See.
All of these things are like very important and you have to know everything. Okay. Data pre-processing,
Data processing. But
pre-processing. Also, a very important part, EDA, right? Yeah, so one more thing, very important. I'm gonna tell you now. See, what we do after doing data cleaning and everything, after data cleaning, what we do is doing our EDA, right?
yes, ETA.
In EDA, what we do? First movement, second movement,
Yes.
third movement, and fourth movement, business decisions, right? We have already discussed about that. Our business decisions. right?
Right.
Also, after that, we are gonna use our hierarchical clustering. We have to cluster the data. But my question is, all of these things, what we have discussed, is working on our historical data, a type of historical data. Historical data is the data which is already stored somewhere, right? Already stored.
Story. Okay.
So this is our historical data. So all of these things are gonna work on this historical data only, right? What if we have some live data? Live data is, you can understand by the name, live data is something like a data is generating every second, right?
Right.
If we have type of live data with us, can we use EDA and hierarchical clustering and all of these business movement decisions into this live data or not? Can we use this?
I think no.
Yeah, right. No. Why?
No.
Because we have stored data, we have some stored values,
Mm.
and
Yes.
that's how we are gonna code like how in a Python to use EDA hierarchical clustering on this data. Like we, because we already know we have some fixed values, right?
Right.
But when it comes to live data, the values are changing every second. Every second,
Okay.
we have some new values. So we do not use EDA or hierarchical clustering or these old methods. These are our old methods. These are
Okay.
working.
All method. Okay.
Yeah, these are working, but this is old methods. We can only use these methods on our historical data, but can't on live data. So what if we have to work on live data? Because see, more or more companies, banks, and everyone is working on live data now. If you are a data analyst at a company, any company, or any application related company, data analyst on any company, right?
Happen. Yes.
Related to bank or something, they have huge data. Also, they have live data. Users are creating data live. So the data is still changing again and again. That's why we cannot use EDA and our old methods on this type of live data. If we want to
Okay.
work on live data, we have to use auto EDA.
Okay.
This is the latest term. It is the latest update, latest model, okay? Or you can say latest method, auto EDA.
It is. Okay.
I will, I am promising you to teach you auto EDA,
Mhm.
but I have a condition.
Addition.
For that auto EDA, first you have to clear everything what we have discussed till yet. First you have to clear everything. Then in a last, whenever we are closing our sessions, whenever we are on the our last date of last days of our course, then if I am satisfied that you have practiced a lot, you know everything, you have a knowledge of everything, basic knowledge, then I am promising you that I will gonna teach you auto ADA. What is auto ADA? And auto ADA is the most demanding skill right now in a market. I will show you. See, this is the key aspects of EDA: data visualization, summary statics, data cleaning, pattern discovery, hypothesis generation, and data transfer plan. We have already talked about everything EDA. But when we do auto EDA, see, automated exploratory data analysis, then this is something new in market and works on live data. See, there are no difference between EDA or auto EDA. But what is auto EDA? If I'm gonna tell you, this dark blue price uh, graph is use of EDA in a 2021, and this gray part is auto EDA, right? So you can see here, year by year, it is increasing. Auto EDA use is increasing. EDA is also increasing, but the use of auto EDA is increasing very much in a market, right? You can see here also the gray part. These are some industries where we use EDA or auto EDA: aerospace, automotive, consumer electronics, medical, telecommunications. So the use of auto EDA is increasing day by day. Why? Because every company, every startup, or everyone is trying to work on live data. No one wants to use historical data to take calculations, to take decisions for their business. Okay. Also, in a freelancing market, as I am also a freelancer, I work on projects. More or more projects are based on auto EDA now. Currently, are you there, Ali?
Yes, I
Okay.
am
Currently,
listening.
I am working on a project. This is a secret project. I can't disclose which company of that, but this is a project about a hospital. I'm working on that right now. Hospital based on Dubai.
Oh,
Based on Dubai, the what I am working on, they want like whatever patient they have, they are updating the data live on a data set. Daily, they are updating the data. So what their problem is, the business problem they have is when someone is getting cured, like if 100 patients are coming daily, for example, 70 of them are cured, 30 of them are not, right? So their business problem is they want to increase this number, cured number. That's why they are asking me to calculate everything based on data, that why they are not increasing in the number of cured patient. See, everyone wants to make or to create their accuracy as high as possible, right? Hello.
okay. I'm here.
They want to increase their accuracy, right? No one wants
Right.
to, like if a hospital, for the example this, if they are only curing 30 people out of 100, and 70% of people are dying or not getting cured in this hospital, do you think the business is gonna grow?
Okay.
Do you think this business
Mm,
will gonna grow if the only 30% people or only 30 patients daily getting cured?
no,
No, right? That's why they want to
no.
increase the accuracy, and that's why they are giving me this problem that please work on this live data. We are updating daily, every minute, every second, or every hour, and give us a output that what are the problems we are facing. I have already worked with them on a historical data. Historical data. I have already worked for them. They are already my client.
Yeah.
But the problem is I have submitted this project to them last year. But before that project, they have a very little business. But now they are expanding all over the Dubai. They are already like two or three hospitals, very renowned hospitals. But they want to expand more to five to seven. Their target before 2025 is to make five to seven hospitals all over the Dubai. So they want first to like solve this problem of getting cured people, because they, for a hospital, for a hospital, the best marketing is word of mouth, right?
Yes.
If I am there in Malaysia and I have some type of health issue, I will ask you, ki, hey Ali, can you suggest me some great hospital or doctor personally who can I contact for this my health issue? And you will gonna tell me, yeah, this doctor is very good. I know him. He's a very good, and the percentage of getting chances of getting cured is very high because he is good. So you can see the word of, sorry, I have 10 word of Malaysia. So the word of mouth is the best marketing for hospitals. So that's why they want to expand their cured percentage, patients percentage, to like expand the word of mouth in all over the Dubai. So you can see I am working on a live data here. So I'm using auto EDA. If I don't have knowledge of auto EDA, for sure I am not gonna like solve this problem with EDA. Because for as a size, I am giving you an example. Daily 3.5 GB of data they are updating each day on a data set each day. And you know 3.5 GB of data is very huge. So this is a perfect example. Like in a market right now, people wants to clients